हरि करना।
Now we have seen most of the laws from probability. So now it's time to address the elephant in the room. That's our Bayes theorem. So Bayes theorem is a way to update our beliefs about something when we receive new evidence or information. So it's based on the idea that our initial beliefs, also known as prior beliefs, can be revised based on the new evidence, also known as a likelihood. Of course, that's how the human way of living works. You will have some beliefs, you will have some accumulated knowledge, and then as you witness new things in your life, obviously you will revise your existing beliefs. You will revise your existing beliefs, and then we can call it as a old beliefs, and or prior beliefs, and you will come up with the new beliefs. Okay, that's how the human life works, and Bayes theorem also works similar to that. So Bayes theorem is a way to update our beliefs about something when we receive new evidence or information. It's based on the idea that our initial beliefs, also known as a prior beliefs, can be revised based on new evidence, also known as a likelihood. The new evidence is a likelihood. So here is a simple example to understand it better. So let's say you have a headache. Okay, let me put it here. So Bayes theorem. Example, let's say you have a headache. Okay, and you want to know the probability of having a brain tumor. So now you want to know the probability of having a brain tumor. Having a brain tumor. Having a brain tumor. Okay. So now you might initially think that the probability is quite low. Maybe that's your initial belief. I'll say prior belief. Prior belief is you might initially think that the probability is quite low, say in say 1 in 1 lakh, 1 in 1 lakh. So that's what your initial belief or prior belief. This is what we call it as a prior belief. So now let's say you go to the doctor. That's the prior belief. Now let's say you go to the doctor, go to the doctor, go to the doctor and get a scan, and get a scan, and the scan comes back abnormal, so this is your new evidence. So this is what we call it as a new evidence. This is what is called as a new evidence. So based on this new evidence, your likelihood of having a brain tumor has increased, yes or no? So based on the new evidence, your likelihood of having a brain tumor has increased. So let's say that now the likelihood ratio is, this is called likelihood. So let's say that the likelihood ratio is 50 is to 1. which means that the evidence is 50 times more likely to occur if you have a brain tumor than if you do not. So which means that the evidence is 50 times more likely to occur if you have a brain tumor than if you don't. So using Bayes theorem, we can update our prior belief to get the posterior probability of having a brain tumor. So with the Bayes theorem, we can update using Bayes theorem. We can update our prior belief to get the posterior probability of a brain tumor given the new evidence. Very important, given the new evidence. So here is how we calculate that. So we have now we have to calculate the posterior probability. Posterior probability is equal to, so obviously prior probability times likelihood. Initial probability we know, then likelihood, we got the likelihood whole divided by the evidence. That's it. That's your probability. That's your posterior probability. So now let's plug the numbers. Now it's time to plug in the numbers into this equation. Let's plug in the numbers. So what's our initial one? 0.0000001 multiplied by 50, and that's what the likelihood, and divided by evidence. So it's 1. So total your posterior probability has come to 0.0005, from 1 in 1 lakh to the 1 in 5,000. See how the things have changed with the evidence. So the posterior probability of having a brain tumor given the new evidence is 0.0005, which is higher than our initial prior belief of 0.00001. So this is called Bayes theorem. If you are not sure, if you did not get me exactly, then I have no issue in explaining one more time. So let's take no, let's understand in a much simpler term. So Bayes theorem is a way to update our beliefs or knowledge about something based on new evidence or information. This is very important. Bayes theorem is very important for the machine learning and artificial intelligence. Very, very important. Very, very important. It brings a huge difference. So now let's take the much simpler one. So imagine you have a belief. You have a belief, or let's say hypothesis. Belief or hypothesis about something. Okay. Like the probability that it will rain tomorrow. So hypothesis, or the probability that it will rain tomorrow. The probability that it will rain tomorrow. Okay. So now you assign an initial value, initial probability to its belief based on your prior knowledge or past experience. The much simpler way. So that's your prior probability. So based on your past experience and accumulated knowledge, and you accumulated beliefs, you have some amount of probability that so if you ask what's the probability it will rain, you will tell that's your prayer probability. Okay, based on your you will assign an initial probability value to this belief based on your prior knowledge or past experience. That's your prior probability. Now suppose you receive some new evidence like the weather forecast. Now evidence time. Now it's time for evidence. Now you have received some evidence like weather forecast and weather forecast, so that can help you update your belief. So Bayes theorem allows you to combine your prior belief with the new evidence to obtain a revised or updated probability. That's it. Pretty straightforward and simple. So what Bayes theorem does is Bayes theorem allows you to combine your prior belief with the new evidence to obtain a revised or updated probability. This updated probability is called posteriori. So in simpler terms, Bayes theorem is a way to update what we believe based on new information. It helps us make better predictions or decisions by taking into account all available information. So that's what is your Bayes theorem. So now how to calculate this? Let S1, S2, S3 and S and so on Sk be mutually exclusive. This is very important. The events should be mutually exclusive and exhaustive events. We have seen what is mutually exclusive and what is exhaustive events with prior probabilities. This is what everyone has, the prior probabilities. So S1, S2, S3 and so on Sk are mutually exclusive and exhaustive events, and they have the probabilities of P of S1, P of S2, P of S3 and so on P of Sk. If an event A occurs, the posterior probability of Si given that A has occurred is this. So P of Si, that's an event. P of Si, uh, the posterior, obviously this is your evidence. If an event A occurs, the posterior probability of Si, because these are all old, these are all prior properties, not present. Old prior probabilities. Okay. So S1, S3, S4. Now you need to calculate the latest one. Now, but you need a support of evidence. That's what is this. It's saying probability of posterior probability of Si given the evidence is equal to posterior probability of P of Si times P of evidence, probability of evidence given that Si all divided by summation of all the calculations for each and every old probabilities or prior probabilities for S1, then S2, then S3, then S4, then S5 and so on it goes. So that's what so for I is nothing but the subscript I is nothing but 1 1 2 3 4 and so on K. That's what is your Bayes theorem uh, in mathematical form, in equation form. So that's what the proof you can see here on the left. And then right, I just want to add few more terms. That's this is what a Bayes theorem. So probabilities, if you take here in this case, you know, if you put it in different way, probabilities of P of Si, here in this case P of Si are called a priori probabilities of events Si, you can replace I with 1, 2 and so on k, and probabilities of Si given A is called as the posteriori probabilities of Si given that A has occurred. That's what is your Bayes theorem. So normally this is one way of representing the Bayes theorem, this is another way of representing the Bayes theorem. So that's the reason I put both ways, so that you will not get confused, because many of the engineering texts will go with this kind of representation. When it comes to machine learning, we'll go with this kind of representation. So I put both the representation so that you won't have any confusion. Okay, so that's what is our Bayes theorem. So example, so obviously disease and then symptom. Symptom is your new evidence. New evidence. So probability of posterior probability, it's better to say that way, posteriori probability of disease given that evidence symptom has occurred is equal to probability of disease multiplied by probability of symptom given that disease occurred, whole divided by, you have to do your rest of the calculation. But here it's a simple one, probability of disease symptom. You can go for the normal calculation also. Okay, that's what the overall Bayes theorem is.